Hello everyone. In this video we will talk about force system resultants. First, to start off, a moment of a force m0 is the force times the distance. Now it's the force times the perpendicular distance to A. So let's say we want to get moment A from the force. This is going to be F times D. And basically let's say the force is 60 Newton, the perpendicular distance is 30 meters. So the sum of the moment about A is Fd is 60 times 30, which gives us 1800 Newton meters. And same here, let's say we have this sort of link. This distance is 4, and here this is 3. Now if we want to get the sum of the moment about A, it's going to be 60 times the perpendicular distance. And the perpendicular distance is this over here. So we have 4 and the 3 cosine 30. So we just multiply 4 by 3 cosine 30. Now let's say we have a simple link with a force 60 newtons in the direction x, shown here. The sum of the moment is 60 times 4, 240 Newton meters. Now next, this is a very important topic. We will talk about cross product. So let's say C is the cross product of A and B. Now note, direction is very important in cross product. A cross B is different than B cross A. A cross B is actually negative B cross A. Now if we cross product the unit vectors, I cross J gives us K, J cross K gives us I, K cross I is J. Basically you can just look at it as a circle, and going clockwise gives us positive, counterclockwise negative. So I cross J is K, I cross J is K, K cross I is J, and so on. Now to do a cross product we can just do a 3 by 3 matrix as such, and we put the ijk on the top. Now the first vector is here, so we have ax, ay, az, and bx, by, bz. Now to start off, for I, we circle I, and then we cross here, and basically it's gonna be ax, by, minus by, az, ay, bz minus by, az. And the j term, we cross here, here, it's gonna be ax, bz, bx, az. So ax, bz minus bx, az. And k, just cross here, we do this x. So now k is gonna be ax, by minus bx, ay. And so the vector is gonna be the sum of these three. This is gonna give us C. Now moving on, so the moment about O is basically of force is the direction vector R cross product with the force vector F. So, and this is actually the same thing as the magnitude R times F sine theta, which is the force times distance from what we have seen before. So now let's say we have this sort of link. We have a force F 5 newtons in the direction shown. So to get the moment O, basically we just set up ijk, and then we have Rx, which here is 0, Ry, which is a 3 cosine theta, Rk, 3 sine theta, and then the same for Fx. Here we have 0, we don't have force in the x direction. Fy is the 5 sine 45, and then Fk is the 5 cosine 45, and this, so basically MO is R cross F, and then we can do what we learned before. We multiply these, then the same thing for J is 0. So J is gonna, we already see that it's gonna be 0 and 0. So we only actually have an I term, which is gonna be 3 cosine 30 times 5 cosine 45 minus 5 sine 45 times 3 sine 30. And this is gonna be the moment vector. Now remember, this is a moment vector. Now next, we will talk about moment couples. So let's say we have the same force, F1 which equals to F, and F2 which equals to minus F, so same magnitude, just opposite direction, and we have a distance d from the two of them. The moment from the force couple is F times d, just the magnitude. This is the moment of a force couple. Now, we will talk about reduction of a simple distributed force. Let's say we have this bar of length L. We have a distributed force on it as shown here, W equals W of x, so the force is a function of x. Now to get the total force, we just do the integral over the length of Wx dx, and to get the position, it's the integral over the length L, x Wx dx, shown here, over the force, which is the integral over L Wx dx. Now we can do an example about that. Let's say we have this bar here, length 3 meters, W is 2x. So first we want to know what the force is. We just do the integral over L Wx dx, which is basically integral from 0 to 3, 2x dx. So integral of 2x is x squared. We integrate that from 0 to 3, we get 3 squared minus 0, which is 9 newtons. And then to get the position x, we do the integral from 0 to 3, x to x dx, over integral from 0 to 3 to x dx. Now doing all of that, we get 2 meters. And then finally, we want to know what the moment is about point O. So as we learned, it's just going to be the force times the distance x. So this is actually, Fr is going to be somewhere around here. This is Fr, it's 2 meters away. So we can see that the moment O is just the Fr times x bar, which is 9 times 2, 18, which is what we have here. And this basically summarizes this chapter. Thank you very much for listening.